Hello. Time to begin again. Get back to it. Lovely Windows task view there. Yeah, it's been 6 weeks, so I've made a number of changes to my entire setup. I'll just load up Streamlabs to check that it's all working fine. Have a new webcam. Yeah, have a new webcam, which is gonna be, well, it's a, if you remember what I had previously, it was the medium shit Moto G3. It was a phone. I was using Droid Cam on a phone, whereas now I actually went out. Wasn't cheap for once, just bought a webcam and it's pretty good. I think. I don't know. It's a really narrow window that I have to test it, so I hope it works well with the Strim. But I have a really narrow window to test it if I want to return it via Amazon. But I mean, what? Should be okay. Should be okay. Should be absolutely down with that. Um, of course, yeah, because technology is a bit shit. I can't directly link it to Streamlabs. But I think, I don't know, compared to my previous streams, if this is a lot more, if it's a lot more, as in the motion's a lot crisper. There's a lot less of the sort of motion blur that you tend to see. I mean, I would have had a crap ton of motion blur if I'd connected the webcam directly to Streamlabs. So instead, I had to open Windows Photo app. Here it is, camera, and have it do a game capture on Streamlabs, which I guess is what you use if you want to capture a video game you're playing on the PC. It's like, record this if it's full screen or if it has a particular name, and apparently I can game capture the camera. But what this means in practice is I'm not allowed to minimize the camera, or else this happens. Ooh, bookie, 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 bookie. But then if I just double tap, maximize and minimize, that fixes it. So I just have to make sure I don't minimize the camera. So I'll be checking perhaps a bit compulsively to make sure that all that is in order. When I was testing, the laptop basically just caught fire almost from the level of the amount of heat. I was doing a stream test. I'm not doing a stream test now. I deleted the bandwidth equals true flag, I think. Bandwidth test equals true. Yeah, so this should be genuinely live. It's a shame that Streamlabs doesn't actually tell me that, although it's saying like you are live, and I did remove the bandwidth test. Like I explicitly remember doing that. So yeah, I just remember the paranoia of thinking, oh, maybe this isn't working, but well, it should be okay. I did everything correctly. I'd be very confused if it were not okay. Yeah, so I mean, the laptop almost melted down. I was setting up my stream while watching someone else's stream a couple of days ago, and that basically caused it to, like, the fan just tracted. It started rattling like fuck. Um, I was just hoping it would be okay and not come back, but then during the test I did after that, like, the rattling is there. Somebody from Dell is going to come through and repair this laptop at some point. I have to schedule that shit. But as for now, it's just kind of. This is the cool thing about having a nice kind of slick camera, is that you can do like this kind of stuff, and it's like actually gets captured, so I can gesticulate hard. I can gesticulate right at the camera, which should be fun. Fun for probably just me, to be honest, but should be alright. So yeah, I went out to Wilco, the random hardware store, not the band, and bought a fan. So I've just been leaving that chilling, and I made a small stand for the laptop out of Mega Blocks, I think. Stuff I have in my room, I still haven't cleared them out. See, Mega Blocks are useful apparently. I made a stand, and now I just have this little fan pointing directly at the sort of laptop vent area and trying to clear all of the hot air out, like an exhaust. So yeah, it's working pretty well. I mean, the laptop fan has not turned on at all. I think it's completely off. I'm streaming, literally streaming. Check it out. I'm streaming, but it's only at 66 degrees or so. No fan, no throttling. Because it was throttling like hell when I was testing it. So yeah, I mean, I'm pretty happy with that. To be honest, I think that's worked out very well. I had to improvise that last day, so I'm glad it did work out. Other than that, yeah, and obviously the fan's fetching air from the massive window that I have out there. So yeah, I'll tell you, I'll tilt to the window. Why not? Show you guys my neighborhood again, because I can just yeah, I guess I can just pick up the webcam. It requires me to like detach this Connect stand in 4 places, but in principle I can do it. Whoa. Just yeah, drag the cable out, give myself a bit of slack. Check. So this is the stand. As in, that's the stand I was using for the Moto G3, if you remember. But then I also have this. Well, I mean, I've detached it, like the 2 yellow rods that connect this with this and this with this, and the are where I attach the camera, pretty much. Bit of cameraing. And just to show you guys the outside, because I can now quite easily carry the camera around. Just don't drop it, please. The estate in Hammersmith doesn't actually have anyone on it at the moment, which is nice. But yeah, I mean, I've had this fairly loud family that lives across, which has thankfully just like disappeared. It's all good. Don't need to be dealing with listening to them speaking in tongues. Don't know what language. Probably Arabic. Fuck, moth. Piss off. Whoa. I knocked it and it went straight onto my hand, but of course I now have the fan, so I can just... Rip. The fan's not powerful enough to take out the moth. Whoa. And the stand is a bit shit as well, but... Okay. Cool. Never mind, I think I'm okay with having the moth there. So what's wrong with this thing? Come on. Oh, right, that's what's wrong with it. Connects is not that easy to do blind. I don't know if people have blind Connects competitions, but this is a bit sketchy. Stand with this fucking like lever system to like set the camera straight. Seems to be mostly working fine, but it is a bit difficult to get exactly the right angle. But this is, let me just relax. This is pretty good. And I can also manually focus the camera. It doesn't autofocus at all, which I think for most people who use webcams, autofocus does more harm than good. Manually focusing it, you can literally get it exactly where you want it. And because people don't move out of the position from which they're using the webcam, this is really the best way to do it. You get sort of a perfect position. Okay. Cool. Sorry to prattle on about all that shit for 10 minutes. I'm just trying to settle myself down and get hyped for all the shit that is to come. Lovely chill laptop setup. It's just worked so hard to set this up this way. Well, it's still 80 degrees, so the fan might turn on. It probably should turn on, to be fair. just help out, help with the effort. But as it is, I mean, it's pretty solid, isn't it? Yeah. Cool. Yeah, anyway, time to get back to work. Don't know if you, actually, sorry, what I will quickly do first is blow my nose. I mean, the cold that I had before, it's not gone away. I'm forever gonna have a cold because I'm just a cold kind of personality. Uh, yeah, a cold, type person. I don't know how you would even say that, but I mean, some people are just prone to colds like nothing else, and I think I'm one of those people. What do I do to turn off like video and sound and whatever? Is it like I can't remember my shortcuts? It's like control. Yes, control 9 to turn it on and control 0 to turn it off. I'm coming at you from West London, um, which is enduring some absolutely monged heat wave. It's like 30 degrees for the next 5 days in a row, and it's been this hot. I mean, the entire World Cup, the entirety of GDQ. I was just falling asleep. I could not handle it. Like, first of all, we have a slightly dodgy sleep schedule, and then you just realise you can't. Like, the World Cup is just a football match is just watching 2 hours, more or less 2 hour, 90 minutes and a bit of just green with some stuff happening on it. But the screen's mostly just green, and then like people talking, and I just like every fucking time. GDQ wasn't much better because I'd come to my room with this laptop and it would just overheat me, and I'm sitting in my bed. It would just overheat me to the extent I just fell asleep. I would just fall asleep over and over. So I just about survived that. I mean, with GDQ, absolutely, I had to move to my desktop. I don't have a desktop computer, but I have a desktop. Um, fucking fingering the moth over there, middle fingering it. I have a monitor and a kind of keyboard and whatever. It's just the computer itself is lacking, so I connect a laptop up. But yeah, for the most part, that's that. All right, cool. So, yep, that is just me reintroducing myself, and now I'm gonna start, get to work. I'll just post a quick message in chat that that's what I'm doing, because it's been 14 minutes of not much. Now get to work. Oh shit! Yeah, I forgot to load my chat app, Chatty, Chatai, which makes like a ding every time someone posts something. So I'll just connect that up. Yep, I've joined myself, my own stream here, programming, no chat rooms available. Okay, I don't know what that means, but yeah, pretty much. This should make a ding. Let me just test it out. Yeah, and it comes up on the stream, I remember that much as well, but just from my perspective, it's just kind of looks like that. So, yeah, don't touch the camera, don't touch the camera. Alright, cool. So yeah, ready to go. I am, yeah, I'm freaking terrified. I mean, okay, I'm glad that my streaming setup is working. I was terrified that that would not work as well because of the whole heat incident, and it took me a while to just set up the webcam as well. And I had to rebuild my Kinect stand and make a new Mega Block stand as well, which is just a few blocks that are under the laptop by a fan, whatever. But the actual work is kind of a struggle because I left it 6 weeks ago. I worked on it for a week. As in, I worked. Okay, so this is project 2 out of 4. It's lab 2, Raft. Lab 2, Raft. Okay. Lab 1 I did first of all in about a week. Then I took a week off, a week and a bit. Then I spent a week on this, and then I took 6 weeks off for the World Cup and a bit of I don't know. What else was I doing? Yeah, GDQ. Went to Cambridge as well. So yeah, I have to get back into that with I haven't looked at it at all. I'm sticking to my what you see is what you get principle with the stream. So I haven't looked at it at all. Instead, I'm just going to flick through all of the notes that I made. I made bare notes. I made so many notes. Flick through those, perhaps rewrite them, and then I'll be in that kind of position where I can just like do it. I can just do it. Hopefully, if I've understood it. I don't know. Some things in linear analysis, my third year maths course, my favourite one, it took me 5 attempts to understand, as in I had to rewrite a proof about 5 times until I finally understood it. This is, I don't know, I think the second time should be enough. But it's weird. It's weird in computer science that it even requires a second attempt. Like, I would say computer science is not that abstract. It's just kind of Raft is very complicated. It's very convoluted. Well, convoluted is a strong word. I would say that's being a bit mean. But it's just like really complicated because the what Raft is, yeah, is a distributed consensus algorithm. So that's what that's what I've started calling it now. It's about, well, I mean, why not just quickly read this? It's like this is not useful. Yeah, I thought I could find like in a paragraph. This is what it is. I mean, it's about establishing consensus, as in redundancy, having lots of, basically, essentially, just having lots of servers doing exactly the same thing and syncing them up so that they're consistent with each other. But we only need one of them to really be alive to handle the service. But in case it goes down, we want this to persevere. So instead of having one, we have like n. There were 3 in the tests I was doing for part A of this project. But the idea is the majority have to not only be working, but also be agreeing and communicating with each other in order for the entire algorithm as a whole to keep progressing. And then it's all about just keeping everyone resynced. Even if the network gets partitioned, so that like we have the server split into 2 groups that don't interact with each other. Once the partition goes away and they can communicate with each other, it's all about ensuring that the dominant version wins, the one that's in the cluster that has the majority. If there is no majority, the algorithm just pauses. There is a lot to, I mean, distributed systems is not easy. Like, there's a lot to say at any given moment about everything, which I've found, like, when I was doing the streaming before, I just continually repeated myself, like, trying to summarize everything, because there's just so much stuff. But, yeah, I mean, hopefully, I'm going to go through it now, spend about 2 hours, hopefully not longer than 2 hours, just, trying to, fixate on the important information. Well, I mean, all of it is important, but just like get it sort of condensed and simplified and kind of make it feel like there's not that much going on. Basically just index it all in my head. It's difficult. It's really difficult to stream this kind of thing. Obviously, people who just jump in are going to struggle really to understand Raft because it's so complicated. What I do, I mean, I don't know if anyone's watching now, but what I do is my Twitch page on the bottom right on desktop. There's a quick resources list, and that's basically links to everything that I'm actually using. And the blue, no, sorry, the guide to Raft is a good a kind of 10-minute introduction. Anyone who's interested in computer science can understand vaguely what Raft is just by flicking through this 10-minute thing. It's the secret lives of data.com/Raft. And there should be a link to that bottom right of my Twitch page. The blueprint is my is the Raft paper. The kind of academic paper for it has a specification basically, which is contained in one picture, one A4 picture, and that's the whole thing pretty much. Not absolutely everything is there, but more or less, I'm just trying to do that. Yeah, I'm just trying to implement that, and this keeps telling me try your best to implement Raft according to as closely as possible to what the paper is saying you should do. So get it to do all that shit. Yeah, so that's that. I also have a kind of link there to the some of the sketches that I've been doing. I think the most important one is called Raft Sketch. So DS source code. Oh no, sorry, it's not there. It's in the scrap folder. I'm gonna have to go through all this shit. I'm trying to remember what is what. At the moment, I don't really remember that well, but Sketch I know is the basic blueprint for Raft. It just kind of covers everything. So I'm going to go through all this and perhaps re-summarize it, just try to make a new text document that kind of conveys what I'm doing. Maybe paper and pen would be better, but it's a bit of effort to show that on the stream. So I'm like, why do I have all these fucking notepad documents? Indeed. So this, I think, I linked to, because I have it all up on GitHub. GitHub.com. My GitHub handle is PYOROT, which is the character from WarioWare, the bird, with a T at the end of it. Basically, that's what that is. Pirate. Pierrot. Pierrot. That's the one. Yeah, so, basically that's that. So, yeah, I'm just going to go through all that, and that's going to be my beginning. 2A, yeah, I remember this document is a summary intended for part 2A, which is the part that I've done. I guess I can technically prove that I've done part 2A to you right now, if I just go, how do I set this up? I'm in DS, I'm in the right folder. .init.sh sets the folder to Raft, and then I can just run go test run. Run is the regex test name matcher, and then if I type in 2A, that should test everything in 2A. I'm also gonna just send it all to out so I can read it in my own time in a file, which I feel is it's a bit better to do that. It seems to be a bit cleaner, and the chavs are back. No, maybe I'm being a bit judgmental calling them chavs, but they do just kind of take ownership of the estate. Pile of children, like this really fat guy who just swears at passers-by, and they just kind of, I don't know, live there. This is their kind of home. I mean, this is obviously, for me, an estate is a prison. I can't really deal with it, but they seem pretty comfortable. Ground floor flat, bare children. Everyone's just a little bit fat. Well, if they're happy. Rah! What's happened here? Can't find run. It's called go test run. Sorry. Run is a flag. Yeah, it is. Run is a flag. Yeah, basically this should just, do something after about 20 seconds. I'm back on, I don't know why it says go here. This should be git bash is what this should be. I mean, there it is, it's done. Basically, yeah, I had to, for the first project, I had to install some sort of Ubuntu emulator because Unix sockets aren't implemented in Windows 10. And they still aren't, even though there was a update that was supposed to implement them, they failed, basically. Well, they cut corners to the extent that it just didn't work. But yeah, I had to install Ubuntu for that project. But this one simulates RPCs. RPCs are remote procedure calls. They're an internet protocol for communicating. I think there's an internet protocol, I'm not sure. It's a protocol of some sort to communicate between different servers. And those require Unix sockets, which I don't actually know what a socket is. I'm not web dev fail, but yeah, it's some sort of tool for communication over the internet. And Unix, obviously, like those don't exist on Windows, so I had to install Ubuntu. But this doesn't use Unix sockets. Instead, it uses its own kind of. I'll show you. Lab RPC. See this thing? This is a package that replaces the actual RPC package, which uses Unix sockets, and it uses native Go channels instead of Unix sockets. So it works on Git Bash for Windows, no problem. So I'm gonna be quite at ease with just using that shit. Does this work? Do I get a choice between never show again and forcefully enable? Let's go with never show again. Hope that doesn't cause a problem. Yeah, so I have my fucking ridiculous notation here, which I have to deal with. Past. Yeah, you have to kind of run these tests separately from each other because it messes up if you don't. But I would say, I don't know, this, oh my god, this is long. This file is massive. Did it pass in the end? Yes, it did after 12 seconds of 756,000 lines. Yeah, this was, when I left it at the end of session 6, which was 6 weeks ago, this was all working fine. This is all of my debugging stuff. So all of the print statements that I put in, I'm gonna have to remember how I did all that stuff. So it says here var p equals fmt print learn. What I can also do is replace p with an empty function, and so if I do that, then every print statement will just mysteriously disappear. So let me just test that out to ensure that it's working. So these are my debug print statements. Problems. Too many arguments in call to p. Have int string once that. P should just be fmt print learn. So yeah, this should be a This is just Go technicalities about getting the function signatures to agree. The kind of dot interface thingy, without being really bothered to explain what that is, I vaguely know what that is something that I can use to get this to accept arbitrary arguments, hopefully. So I saved it. This didn't quite work. Can I use function literal as type function interface? Okay, one of them outputs int error and this outputs nothing. FMT print learn. Should we just try to get the return signature to match as well? Does that work? Should work, surely. Hello? Yes, it works. I'm just chucking a return here because I want this to be an empty function. Not enough arguments to return. This thing is a fucking joke. Like I have to boilerplate everything, don't I? I have to return an integer which is just going to be 0, and the error I'm going to return is something that has type error. Oh dear, no definition found for error. This is not going to work. What? God damn it. Go is, yeah, I mean, it's too strongly typed for my liking, right? I don't know how to do the thing where you can just define your own print function. You know, I'm trying to just hack that now to get it to work. So it takes arbitrary shit, returns int error, and I'm trying to return a valid error. I guess like if I boilerplate it much more extensively, I can go error is defined as a new error. Oh dear, I've actually forgotten how to type go. I'm starting to, this is going to slow me down. Cannot make type error. What do I want to do here? I want to declare an empty error variable. So var error is the name and error is the type. That should work. Sick. Okay. So now, yep, let me just run the tests and prove that that actually does what I want it to do. Which is, this should now just literally, because I disabled the print thing, I disabled the print, all of my custom print statements. So I was using the p function for all of my custom print statements. This is boilerplate for an empty function, as opposed to the other one, which is var p equals fmt.println, which is what this is supposed to be replacing. So I've replaced it with something that does nothing. So I should not get any. After about 12 seconds of testing, I should not get any anything other than test passed, pretty much. I didn't even have to print it to file, but so you'll see what I mean when I show you now. That didn't work. Didn't I disable print learn by using p instead of print learn? Surely I did that. Wait, control Fn end. Yeah, I mean I saved it and I don't know what's going on. Okay, let's pick out a random instance of where I wrote down fmt println. Okay, so here for example, Raft flow, the main thing. I have p. See, I am using p. Go to definition, the function that does nothing. There it is. So why on earth? Why is it printing? Why is it printing when this is the empty function? Okay, let's. But I'm using p everywhere, right? I'm using my p function everywhere. I'm not using fmt.println explicitly anywhere. Yet it still seems to be printing for some reason. What on earth? What on earth is your major malfunction? On another note, what is it called? MIT itself actually provided me with as in the project they have their own debug thing. Where is it? I think it's here. Yeah, they have a dprintf, which is like a debug printf. Maybe I should just use this, because then if I can turn it on and off using the 0 here. But I don't want it to be called dprintf, I want it to be just called p. Do you think that'll work? Okay, what happens if I fully comment out this? So I've commented out my p function, but now it says undefined p. Too many errors, error. Hurrah, too many errors. So now I'm going to rename this p. Somewhere I am assigning to... oh, this is just some shit that's left over from before. I tried something that clearly didn't work, so forget about that. Cannot assign to p. That's what was causing the problem before. That's now been deleted. Can I use rf.me as a type string? Yeah, I think the problem with this dprintf thing is it's not... okay, I'm gonna try to hack this to get it to work. Just keep hacking it until it works. So here it's using, this rf.me thing cannot be used as type string as an argument to p. That's because p should be... this should not be a thing at all. It should not require a bloody format argument. It just needs to print ln is the function I want it to use. It just needs to print ln its input. Fine. Alright, you know what? Okay. I think this should work. Let's find out. So, all this effort just to get a kind of a switch for whether I want my verbose print output debugging to be displayed or not. Right, literally that's all I've been doing. Oh, camera is still working. Yeah. Camera. Nice. Okay, fine. Let's just deal with that then. So, go test run 2a. Because debug is set to 0, it should just say passed. Oh, 2a is... shit, 2a is both the test, isn't it? Still. Now that debug is on, I'm gonna do the same thing. But because I want to cut down on the spam, I'm gonna do 2a1, which is test 1. I mean, this is printing times now, which I feel is unnecessary. That's because I'm using log instead of FMT. If I just switch it to FMT, that should get rid of the times, which are, yeah, I don't need those. FMT is completely legit to use in this circumstance. Settled. Okay. What can I say? That's something I definitely should have sorted out before my hiatus, but it is now fixed. I can now, I'm actually using their own pre-provided file which is called util for unknown reasons. There's no good reason this should be called util. I'm going to rename it to debug. So this is just the debug switch. You know, depending on whether this is 1 or 0, or I guess true or false would also work. Nah, it says greater than 0, so types and shit, but yeah. Whether or not I set it to 1 and 0, it should respectively show or not show all of my print statements in the console or in the file, you know, the out file, whenever I wish to test. Which is important generally in programming. You know, if you're doing print debugging, as in debugging by printing statements that sort of tell you what the program is doing, it's kind of really basic introspection. Whenever you're doing that, it's important to be able to turn it off, so you can not spam, basically not spam hard. But yeah, my P statements are now basically all over the place, but yeah, that's it. Both of the changes I made were just instantly reverted there because of this like style linter or whatever. Alright, I'm going to set one more thing up that I think I might have forgotten to do previously, which is, you see how all of the tests all of them are titled capital test. So yeah, I'm in the test file, which is in the Raft library here. So you can see test, right? All of the actual tests have test with a capital T in their titles. And that's how Go knows the language that we're using. Golang height. That's how Go knows that this is supposed to be a test, and Visual Studio has also picked up on that fact. Fun facts, I mean, when I was trying to test using these buttons, Visual Studio just froze repeatedly, so don't be clicking them buttons. So test specifies a test, and then if you use go test, then it runs all the tests. But if you use the run flag, you can match regex. And it's just a piece of regex that matches somewhere in the name. So like if I type initial, this will be matched because initial is there. Something else will be matched, possibly if it also has initial in its title. I don't know. But the point is, you know, if I type in test here, it will match everything because test is in the title of all of the tests. But then if I type in initial, it'll match this one, maybe some others. But what I want to do is type, you see how 2A is at the end of all of the 2A tests. And 2B is at the end of the 2Bs and 2C as well. So this is project 2 out of 4, Raft. Parts A, B, and C are the questions, basically, that I'm doing. And yeah, basically, those questions have tests corresponding to them that are named 2A, 2B, and 2C. So the one I've added after the 2A is just me numbering the test so that I don't have to type out the whole name if I want to just pick one of the tests. Because, you know, part 2A only had 2 tests. Part 2B, let's fucking count them. 14 tests? Not necessarily, because yeah, it has. You can see it's turned up in the text as well. I think there are 7 tests because each one is in the title and in the comments. So if I do this, it'll 7 tests, right? So I'm gonna number them just so I can test 2B 1, 2, 3, 4 individually, right? So let's go. Just go ahead and do that. Two B 4, 2B 5, 2B 6, 2B 7, right? So that's what I'm saying. Part A had 2 tests. Part B had My God. So dopey when it comes just to speaking what I'm thinking. Part A had 2 tests, Part B had 7 tests, yeah? So the last one is here. It's fucking long. 2B 7. Part C, I think, has 8 tests. Test persist 1. You can see this is, yeah, persister. Persistence is one of the things in Raft that we're going to have to implement at the end. So I'm hoping it's not going to, like, destroy me. Part 2A, it took me so long. You can flick through the Twitch collection. You know, my Twitch page has a section called VODs, VOD, Video on Demand. And if you look at those, I mean, you can see. Okay, so this is 2C4. Next one is 2C5. You can see just from the titles of the videos in the Raft series just how much time it took me just to do Part 2A. So I'm hoping for a bit smoother sailing, but the key thing is that I don't have a deadline. I absolutely do not have a deadline anymore, which means burnouts is unlikely because I can just slow myself down if things are going too badly. This is test 7 and this is test 8. Okay. Churn. God, I wonder what that is. Reliable and unreliable churn. So, okay, all of the tests have now been named, okay? All of the tests have been sorted out, and I can just run them off the cuff like this. Moth. Had the good sense to leave when I waved it away. You know, my code is still kind of doing something, but it's going to fail because it doesn't do anything. Fail to reach agreement? That could mean anything. That could mean anything. But yeah, basically that's it. That's all organized. The testing is in order. The debugging is in order. Thank God, finally. Config is just support for the Raft test. There's nothing. Well, I guess one of the benefits of being on the estate is just people will just smoke cannabis on the street. The smell is just coming in now. I don't know whose window that's coming in from, but I've always kind of enjoyed the smell, to be honest. So I'm quite happy to just have that there. Hopefully it's not going to mess me up. I'm gonna be here for another hour and a half, just working like, and I have a fan that is just blowing it into the laptop as well. Should be okay. Should be okay. It's not that strong, and it's probably just going to disappear like after they open the window properly. Just do a quick test. Should say, by the way, this hat, I just found it like my face has moved to the right. That's annoying. Just fixed it pretty much. Yeah. Okay. I should say, by the way, about the hats. This hat, I found it this morning in like a bag somewhere. This is just a hat that somebody gave me when I was about 12. Yeah, I think my dad gave me this hat when I was about 12, which is cool. It's a nice hat. I just kind of forgot I had it. I don't particularly have any strong affiliation with Scotland, but you know, Scotland, like, welcome to Scotland. It's from Sky. What's the name of that house? Skyloft, Skyrim, Skyfall. That's it. Skyloft, Skyrim, Skyfall. That's the one. Yeah. I think that's the quote from this. Just somebody I know's younger brother produces dubstep, and he made a song called "Welcome to Scotland," and it was like just had that quote in it. And then, you know, then the bass drops, and then the bass drops. Welcome to Scotland. Which is, yeah, what was it, the sort of finale of Skyfall? yeah, was set in a manor in Scotland. It was good fun. Fun film. It's really the only Bond film I've seen, I think. Might see another one. It's just never particularly interested me, but those films are fun. I enjoy watching them. Visual spectacle. Okay, check it. That's it. That's everything. What was I even talking about? Before I got distracted. The smell has predictably gone, by the way, so no stone strim. Alas. Drunk strim, stoned strim. Which is just one of like the feature requests. Because I've been watching people on Twitch more often than I used to. I'm kind of engaged with that. Just I'll give the guy a shout out quickly now. Actually, I may as well. A really fun speed run. If anyone's interested in speed running, Wind Waker HD. That's a Zelda game, yeah. Any percent. It's a really fun speed run. Just like so many really difficult tricks, bit of randomness, and just so many really cool looking tricks and things. Just warping, clipping all over the place, and just ridiculous kind of navigation over this world. So yeah, I've been watching that. Linkus 7, Ian Miles fighting over that record. And yeah, so just chilling on their streams, like the feature request that will always come up is do a drunk stream or something. Um, yeah, well, alright, cool. So that's it pretty much for setting everything up. I like to just. It's 10 p.m. now, and I still haven't actually started going over Raft again, but like. I just like being comfortable in the fact that I've set everything up correctly before I move on. But yeah, let me start. God, I'm starting to cry again because of God knows hay fever or something. So I'll blow my nose quickly again before I pick it up. But the very next thing that I'm going to do is I'm going to start looking over my files and just remember quickly how I've split up the codes and what everything does pretty much. You can actually see immediately, so config, debug, and test, those are just, helper tools. The actual program codes, persister is part of it, but that doesn't come up until task C, part C. So these four are the ones I've been actively working on. Flow, thing, append entries, and request votes. So I'll just blow my nose, and then I'll just quickly talk about them, look through them, and then look through like the blueprint, all the text files, summary. Just I hope I get my head around this fast, honestly, because I just want it to all work out. But I mean, tomorrow morning, I imagine I'll keep recapping. I imagine I'll actually start the work probably Thursday evening. No, Thursday evening I'm going to ask my friend if he wants to just meet in a pub, because Thursday daytime I have a kind of, not even an interview, a kind of meet up with a prospective employer, which should be fun. So Thursday I probably will be busy. Wednesday's tomorrow, yeah? Yeah, so now, then tomorrow morning, tomorrow evening possibly if I'm not feeling too tired of all this stuff, but Friday definitely, I'll just be like, get to work on part B. But for now, I don't know what the hell part B is, and I'm not going to read it until I sort of have an idea of what I'm actually doing. Oh yeah, I can just hover above this, can't I? In order to see my camera position. That's very convenient, I have to say. Thanks, Windows. Sincerely. It's not like when people say thanks, Nintendo, they're usually being sarcastic. Okay, so let me just blow my nose quickly. Sort of set my butt up in a slightly nicer position as well. Did I just throw my tissue out the window? I can't tell from here. It might. I don't want to touch the outside of the window. That's dirty. I just vaguely dusted it just now, but like it's 10. Well, I mean, I say 10 years. It's like 100 years. Probably no one's cleaned that. Window pane outside. Who does that? Know what I'm saying? The laptop is just so cool. It's just so cool because of this fan, which I bought £6 from Wilco. I got you, and it's all I need. And I got you. I don't know, man. You should listen to Being There by Wilco. It's a very good album. Well, I think most people start with Yankee Hotel Foxtrot. It's kind of it's a bit of a hipster album, to be honest. Like it emphasizes texture a lot, but the texture is it's a bit kind of look at me, kind of gaudy and random, and the kind of stuff that appeals to hipsters, to be honest. It's good. Like the texture is nice, but it just kind of strays on that side a bit. But the songs are great, and it still sounds pretty nice. And the first song on Yankee Hotel Foxtrot, 7 minutes of more or less pure texture, with some really really like nice simple melodies, is good. Like it's good, but it kind of bores you after a few listens, I guess. What's that song called? It's like I'm trying to break your heart. That's it. The vocals are good though. I'm an American aquarium drinker, high assassin down the avenue. But yeah, Being There is less popular, but it has none of the pretense. It's not pretentious at all. It's a really straightforward country rock album, and it's just because Tweedy's voice is so resonant and so believable. It's just a really really pretty album. A lot of love for that album. Is that the fat guy? Just chilling there in his vest and beer belly. I don't think that's the same fat guy. Like the fat guy I'm thinking of just like really loudly swears. I literally swore at somebody for like looking at his kid wrong, I think. It was quite strange. It's proper like cunts as well. I think that's what he said. Cunt swearing. Alright, cool. God, the distractions are real. 10 minutes later. Fuck's sake. Alright, let's close all this shit. So listen. These 4 files are what we care about, okay? Flow, raft, append entries, and vote. Basically, there are 2 types of RPC. So these are the calls that one server makes to another server. There are 2 types of those, right? And so I've made files for them, and the files are literally... I'm using the convention specified by MIT here, but basically there are 2 structs. Structs are like objects in JavaScript. They just store data in a very flexible, arbitrarily flexible, basically an arbitrary data structure, I think. In JavaScript, that is definitely an arbitrary data structure. In Go, it's kind of, I think it is still the same thing. Details. But yeah, there are 2 of those, and there are 2 functions, right? And so that is a 2x2 Cartesian product. One dimension is the args. The data that is sent, the struct that stores the data, and the other one is the function that handles the RPC. And the other dimension is the sender and the receiver. So this is the sender struct, okay, and the reason, so it contains the stuff that the thing that sends the RPC sends over, this stuff, and the reply is sent by the thing that receives the RPC and sends it back. So RPCs are two-way handshake communications. A message gets sent and then a reply gets sent back every time. So the sender, and so when we say sender and receiver, we mean the sender is the thing that initiates the RPC, and the receiver is the thing that sends the reply. Okay, so that's the sender and the receiver in RPC speak. So this is the data the sender sends. This is the data the receiver sends. This is the function. This is the function that the receiver runs. This is what happens when the reply is received, and this is the function that the sender runs. Okay, so the sender calls this to send an RPC, and this is also called when the response happens. Right, so the flow of the program is basically, in the beginning there is no RPC, and then my butt's getting a bit dead. Let me just slump up. God, yeah, that's better. Much better. When I do that, I have to move my stand about. How does my stand work? It's a bit strange. Okay. It's a bit close, isn't it? I'll just chuck it back there slightly. Sorry for being annoying with setting up my camera. Actually, do you know what? I'm going to refocus it as well, because I've moved it quite a bit. Thankfully, I mean, refocusing is a bit unnecessary in this situation, but because it's so fast, I just do it anyway. Just make sure not to minimize the camera. Okay, cool. So, yeah, this is the life cycle of an RPC is as follows, right? Something calls the send function. That is, the server that runs the send function is the sender server. A server, peer, computer, all the same thing. That thing, right? It sends it, and then the RPC gets sent, and the stuff that's in the send arguments gets sent as data to the other computer, server, peer that receives the RPC. Sorry, it just bothers me because the camera really does not look dead on to me at all. It's a bit strange, but I just have to believe that the camera is being dead on, and I'll check Streamlabs to make sure it didn't freeze for no reason. Yeah, so basically, RPC, one computer sends it, computer A sends it to computer B, and the life cycle is computer A calls the sender function with the sender arguments. Those get sent to computer B, and then computer B, because it has an RPC, it just received that. The receipt of the RPC automatically triggers the receiver function, append entries, gets run to handle it, and then it sends the reply back to computer A using this structure. And then, when this exit control, the entire act of sending the RPC blocks computer A, or rather it blocks the thread or the go routine, the coroutine. The routine that's running the RPC gets blocked after the send. It's until the reply comes back from computer B, and then it continues. So that's how we can handle the reply. On the computer A can handle the reply on computer B's side, right? Computer B doesn't block at all. Append entries is, I think, automatically run on a separate go routine. This is run and then it just exits out. Okay, so yeah, we don't actually have to think about running append entries or implementing a handler or anything. I'm pretty sure that automatically happens. At least I don't remember coding that. I'd be kind of surprised if that were a thing, considering I don't remember even programming it explicitly. But I think that's how it works in general. So these are just the principles to bear in mind with how RPCs work. So this file handles everything to do with append entries, and this file handles everything to do with request votes, and those two are the two RPCs. Throat, man. Cool. The other two files, Raft Flow is something that I extracted from Raft Go, and I'll show you why in a sec. Raft Go, I would say, really only contains the basic outline stuff for Raft, and it's not something I'm going to be, this file, it's not something I'm going to be, the highlighted one, it's not something I'm going to be working on too much, because it just mostly contains standard stuff. So apply message is, it's another type, which is sent to, don't forget, Raft is a consensus algorithm. It handles, this cluster of servers that is trying to make sure that data is getting processed the correct way, but there is a service, like there's another program that runs on top of this that is receiving information, and there's also a client that's sending information, and so the information is supposed to get from the client to that service, and it goes via Raft, which ensures that the information is, is it integral, like information integrity is ensured via the whole redundancy and replication, which is very distributed. Woo! And so apply message, this thing, is what goes out to the service at the end. So this is kind of the interface with the service. This is not sent via RPC to my knowledge, but the structure is there, and I don't know, we'll find out later. These are just some variables that I'm using to time elections, and the channel that I put in. I can't remember exactly what those do. Well, I mean, I would remember if I sat down, but I'm just trying to briefly flick through it all to start with. The Raft type is something that is run on every server. It represents itself. The kinds of stuff you can just quickly flick through with your eyes, visually. It has various variables that I implemented. According to the specification, it has its own mutual exclusion lock, which is actually a key part of this project. Is locking and unlocking, so that because it's a heavily concurrent program even within a single server. It's not just parallelized across computers; it's also heavily concurrent within a single server. That means that lots of locking and unlocking is going on with this to make sure that we don't get, conflicts, data corruption of multiple things working on the same thing, multiple threads editing the same object. So that's why we've been using the mutex extensively. Mutex stands for mutual exclusion, by the way, which is the name of the lock. It excludes everything else, every other thread other than the one that has the lock. That's the idea of the mutex. And then it's peers, persister, me. Peers is just a list of RPC addresses. Me is myself within the index of peers, and everyone has the same copy of peers. Peers do not get added or subtracted. This is all useful information to bear in mind. That actually just makes the project a bit easier. Persister doesn't exist yet. It is just this thing, which all gets run and blah blah blah. I don't know, but none of this is implemented yet. So it's just okay, it's linked to within the main Raft object. Then we have get state, which is a routine that just quickly returns term and isLeader. Term is a really important state variable that I cannot be bothered to discuss yet. A bit more stuff about persistence. I skip this, and then start, which does something. Oh yeah, starts. What the hell does start do? This is, I cannot be bothered to even read this. I'm just going to read through my interface because I wrote about all this stuff for myself. Starts consensus on new log entry. That's what start does. So it's a dataface thing that runs part of the consensus whenever. Yeah. I think start might be run by the client every time it wants to send something. Not entirely sure. This interface stuff. How does Raft interact with the client and the service that it's, you know, managing effectively, keeping synced up? The interfaces between on those two sides I'm not completely clear with. Most of the work I've done so far is just Raft internals, so I'm not that fussed about getting a grip on how all of that works straight off the bat. Kill is it's just exit codes that is optional, and make just sets things up. I did put, so you can see I did put in a bit of initialization code in make. Make is the thing that the computer runs to initialize Raft server. And like I said about peers is fixed, me is fixed, so all of that is there, and then we just run make on all the computers. And it makes a persister, it makes a Raft instance. Persister, we still don't know what that is. Yeah, it doesn't matter. The burpees. And then my initialization codes here. This is just another thing about persist, but my stuff is just, I set voted for to -1, which is the voted for nobody thing. That's a JavaScript convention. Set -1 in the absence, to indicate the absence of somebody who's voted for. Because 0 is actually the ID of one of the servers. It's a 0 indexed array of servers. There's a print statement saying, okay, I start out as a follower, and I run a phase change to follower. So the initialization code is just saying I start out as a follower. This is all stuff that I wrote myself. And so this is, like I said, this is all state variables, initialization codes, interface code. That's what is in raft.go, the main file. Raft flow is my internals file, basically. And there isn't much here. Init leader, init follower, init candidate, heartbeat, await election, call election, phase change. Okay, those 7 things. Init leader, follower, candidate. Okay, so I guess this is where I start talking about what Raft actually is. Slowly. Tiptoes. Raft, right, is all about, every computer. Raft is basically a democracy of servers that are trying to establish consensus on what is the correct piece of information to pass from the client to the service. Consensus algorithm, that's what it does. It mediates effectively the transfer of data from client to service. And it's a democracy, so it's many servers are running the same thing. None of them is privileged over the others, like there isn't a master and workers the same way there was for MapReduce, the first project I did. Instead, all of them are the same, but they have phases. So temporarily, they can be in the phase of leader, follower, candidate. Leader leads. The leader is like it kind of pretends. Throat is wrecked. The leader pretends. Pretends. The leader basically behaves as if it's just the one thing that is connecting the clients to the service, the user to the service. Yeah. If the leader were guaranteed to work perfectly well all the time, then we only need that one server. But the leader is allowed to fail, and Raft is supposed to continue if that happens. So we have lots of different servers, and the leader, so I said the leader is, one of the servers is temporarily a leader, and what it's doing is keeping everyone synced. it is doing the job of the intermediary between the clients and the service. It's being the intermediary, but it's also keeping all of the other peers it can synced up with the information that it has been dealing with, so that all of them can take over from the leader at a moment's notice when the leader hesitates, if it breaks down. And so they know that because the leader sends out heartbeats, which are the append entries RPC is an RPC that only the leader sends. So a server must be a leader for it to be sending out the append entries RPC. It goes out to all the other servers and just tells them the leader is alive and all is well, and it resets the candidacy timeout on all of the other servers it can get into contact with. Because if it doesn't get into contact, then the candidacy timeout will elapse, and the follower, so everything that is receiving heartbeats is a follower. But if it stops receiving the heartbeats, and candidacy timeout, it turns into a candidate, calls an election, and then request votes. RPCs are sent here and there, and it tries to get a majority. If it gets a majority, it turns into a leader, and it increments the term. And the term is like it's not a global variable because that doesn't make sense in a distributed system, but everyone is trying to keep a copy of what the term is. It's intended to be global, and every time anyone calls an election, the term is incremented. So there are some really important concepts that ensure this. Every RPC, both append entries and request vote, all the RPCs do a synchronization of terms. They update the two computer A and B that sent the up and received the RPC. They have to synchronize their terms to each other, both of them. So after the RPC is done, the computer that, well, both of them have, an up-to-date term, up-to-date among themselves, not necessarily the latest possible term of everyone, but among the two of them, they have the maximum of their terms. And if somebody had a smaller term, that means that things have moved on. It probably lost contact with someone, and it should be a follower. It triggers that to happen. I have a few misgivings about if that's the correct design, but I don't know. It's just because it's so complicated. There's no clear, correct. Well, I mean, usually things do make intuitive sense, but sometimes you're like, I'm not entirely sure conceptually how this should be structured. So the thought that had just crossed my mind is like, is this, is it right for something to automatically become a follower if it had an out-of-date term? Because if it was a majority leader, I mean, the answer is yes. Something needs to get re-elected if the term increases. Because what that means is that one of the other computers at least lost contact, and even if it's now back in contact, it will also become a follower because its term will be out of date and it will be out of sync with the leader and whatever. But yeah, they all get reset, and then whoever the hell wins the following election gets to govern them all. That kind of makes sense. Anyway, that's a basic explanation of what leader, follower, and candidates are. I'm going to try my best to just follow the instructions in the blueprint to say how I should implement all of that stuff. But more or less, that's that, okay? So, when something becomes a leader, it runs heartbeats. Heartbeats is sending out the append entries RPC, and it's tail recursive. At the end, if the thing is still a leader, it actually checks. Heartbeat checks if the thing is a leader. Only leaders send heartbeats. Let's put in comments. Let's put in comments. This should have comments, so I don't have to read 5 lines of code in order to figure out what the hell one thing is supposed to be. This, right? If my phase is not leader, I print that I am exiting from being a leader, and this thing the lock gets dropped and I return, so heartbeat fails to actually happen. return happens at the beginning of heartbeat, so the actual heartbeat code does not happen if this thing is not leader. So this is a leader check. This is the sending of heartbeats. Every peer, if it's not me, I don't send a heartbeat to myself. This is the arguments for the append entries. I define a new append entries argument structure, and then I just send it off in a separate Go routine. The reason I'm sending it off in a Go routine here is because I don't care what the response is. So this Go routine that runs send append entries. So send append entries returns send append entries returns. Oh, send append entries actually handles the reply to the RPC. So the sender, the reply from the receiver comes through to the sender, and the sending function handles that. And the way that works is that it initiates a send. Here, the call is the inbuilt Go library routine that sends an RPC, and that then blocks this function until the reply comes through, and then it continues it. Once the code moves on from this point, the reply has been received, and so this is handling the reply, all this code, right? So that's why if we run Go send append entries, it will start up a new thread, so it'll be concurrent to do the sending. That new thread will be blocked until the reply is handled, and after that until the reply is until send append entries is run on a separate thread, on a Go routine, the lightweight thread. That does the send, blocks until the reply is received, and then handles the reply and then exits. So that blocks the separate thread, but because this is running a separate thread, this just continues. And that has to happen in this case because we're sending the heartbeat out to all of the peers, to many, many man. So this does, it does a lock, leader check, send heartbeats, unlock, fine, and then recurs. Actually, I think the technical term is like recurs. Oh shit! Didn't notice the camera had slipped. Yeah. Okay. I like my stand. I can just push the thing. Pulling the camera up is slightly more difficult. I have to push it from the back on a connects one of the red poles basically. But yeah, I mean that's all absolutely fine. God, I hope the stream is working. I get so paranoid because I have no way of seeing it, and I have no chat interaction. Obviously, doing this kind of thing, just programming on stream. I am honestly. I think I am going to start streaming video games. It's funny saying that, but just casually. Like I might. There are a few things I'd be into streaming, like my Super Metroid blind 100% playthrough. I still have 5 items left. I could get like the stream to suggest where they could be and then just try find them, and then it's like, we did it. And I might start, I don't know, might try like an Ocarina of Time speedrun or Mario Sunshine individual levels, that kind of stuff. World's your oyster. If you have the right equipment, you have to buy a capture card, but yeah. For the time being, I'm just persevering with my programming, my distributed, just teaching myself distributed systems, just because I just really enjoy doing concurrent programming. I have to say, even though it's really, really difficult, I just really enjoy it. When it works, it's just like, the system, the system that I made. So it's great. It's great fun. Yeah, so that's it, right? It's worth noticing, by the way, that all 3 of these are completely redundant. I could just replace init leader, follower, and candidate with these routines: heartbeat, await selection, call election. Quick nose blow, my apologies. I could do that, but I've left them here in case I want the leader, follower, and candidate to do something else. Because this is just the heartbeat, this is just the awaiting of an election, this is just the calling of an election. So the conceptual distinction. Heartbeat, as you can see, recurses on itself. This piece of code literally it just keeps running until the thing is no longer a leader, and some other routine is going to cause it to stop being a leader. And what that is probably an RPC term sync. RPC term sync is my name for the bits of code I have that make sure the terms of a sender and receiver are synchronized every time there's an RPC. That's all absolutely fine, and that's probably what we'll call the leader. That's probably what will cause the leader to stop being a leader. So I always just check before running a heartbeat, and then recurs. Recurs happens. First we sleep for the heartbeat timeout, and then the recurrence happens. The recursion. God, my bloody blocked nose. Where are my state variables? Where did I put them? As in, I wanted to see what my heartbeat timeout is. I always forget Visual Studio Code is not a bad idea at all. If I want to find a variable, all I have to do is right click it. But I lost the initial one as well now. Fucking here it is. Yeah, right click and go to definition. So it's in Raft somewhere in Raft. Heartbeat timeout is 150 milliseconds. I think I specified that according to like the guide or something. I don't know. So yeah, it's pretty clear what heartbeat does. The code here, right? It sends append entries, and I mean it sends append entries, which is I keep talking about a data phase, as in I'm going to be implementing the actual sending of data. The stuff the client sends through to the service. That needs to be handled by Raft. Currently, Raft is not handling data at all, but data will be handled via heartbeat. Wow, okay. Let's be completely clear. Append entries is the RPC that sends data, and append entries is sent out even if there is no data, because the leader has to make sure that everyone else knows it's alive, and that's the point of the heartbeat. So my convention is to call the heartbeat the empty append entries, as in it's either a data being sent or nothing being sent, and the empty append entries I have so far been calling heartbeat. Maybe I'll change that. Maybe I'll refer to every append entry send as heartbeats. But certainly this loop that sends the heartbeat is going to be modified for part 2b to send data as well, because this just as it just sends nothing. So append entries args, term is specified and leader is specified, but the rest of the arg is not specified. So if we look at the definition of this, entries, previous log index, previous log term, leader commit, all this stuff is just left at default because I haven't specified it in the code here. Term and leader ID are specified, but the others are not, and that means that the others are set to their default values. Integer default value is 0 in Go. String what is this? Array of strings. Well, array default value is just empty string array. Yeah. Strongly typed as Go is. God, I'm loving how cool the laptop is. It's running at 80 degrees, fanless. Pretty sure I cannot hear a fan at all, because I have this external fan that's just been really effective at cooling it, and minimal throttling, as you can see. Well, actually, I'm not sure if that is throttling or just idling. It's difficult to tell sometimes, but the fact that it keeps hitting 3392, which is the maximum, I say that and then it goes to 3393 immediately. But the fact that it keeps saying that it gives me confidence, you know. Hour and a half in. End stream. Nah. We are live and we are not bandwidth testing, I'm pretty sure. Unless I really messed something up. I'll tell you what, just to put my mind at ease, I'm going to check, okay? I'm going to check if I am actually streaming to the correct place rather than doing a bandwidth test. To do that, I have to expose my streaming ID, which means that anyone can stream on my behalf just by like copying it. So in order to avoid that, I'm just going to temporarily black screen, like display capture. I can make that invisible just for a bit, and that's just while I check that I'm not messing up. So I go to settings, I go to output. Stream, show, and yeah, it says live bar, some numbers bar, some alphanumerics, really long thingy, and then there is no question mark bandwidth test equals true, which is good. Okay, it's not allowing me to edit it while I'm live. Obviously, that's good. Cool. I'm absolutely happy that there is no way that this is going wrong, even though I can't see it for myself. Cool. Okay, back. Wagwan, you beautiful people. Alright, check it. So that's it. So I went through the idea of how heartbeats work, more or less. Sorry for my capricious scrolling. Raft flow, right? So heartbeats is a really simple piece of code, and it works quite easily, I think. What the leader does, it sends heartbeats. We have some other stuff to think about. What the follower does is it awaits election, and what the candidate does is it calls election. So I'm just going to take myself through that code to remember how it works, okay? So followers await election. So this is the follower code. RF mu lock. I lock the mutex and then I follower check. This is, as you can see, like identical code to what I have here. It would be nice if I could get rid of the redundancy of the code. It's probably possible to do that, but I'm a bit sketchy with doing all that stuff. I've already feel like I've gone quite far with implementing phase change code. So I haven't actually shown you guys any of that yet, but I mean that's already pretty weird, I guess. I don't know. I guess the stuff that I'm worried about is you know, things like, can I access the lock from the right function? If I complicate the code too much, I can't see the lock and the unlock as being in basically the same place. So if I were to chuck this out into a code snippet, that means the unlock would go somewhere else. And if you do that, you then have to have conditions. Like, I can only call this if the lock is already had, as in it has to be locked when I call this function. The mutex rf.mu has to be locked when I call the function. And just having these kinds of assertions that you have to keep on top of is quite confusing, and that's why I'm a bit scared. This is why currently I'm erring on the side of caution and having lots of, I think, unnecessary locks and unlocks, just to make sure that I have no assumption. I'm not making any non-default assumptions for when I'm passing between different functions. That's a good way of summarizing what I'm doing there. All right. Anyway, my butt hurts like a lot again, so I'm gonna move to a different position. God, should I just? I've kind of enjoyed having the camera at the front, but it gives me a bit less freedom of movement because it's just kind of between my legs. I don't think I can clip it to my laptop screen. Yeah, you say that. Actually, there's no reason I couldn't just like tape the metal bar at the back, but then the camera's a bit too close to the laptop. Let me see. Okay, let me just shuffle about a bit and see if I can get into a less, I don't know, less painful butt position. I wanna what I really want to do is, okay, I'm just going to fully move into a new position, just bear with. Oh, my legs. Actually, do you know what, this position's okay. The kind of spread eagle knee position. This is pretty solid, okay. Move the fan so that it's still directly pointed at the laptop. Just bat the moth away. There's always a new moth. And I'm just going to set the camera position up so you can just see my knees there. Why not? Why not just, have knees? Okay, which bar is it again to move? Yeah, this bar. I just push up to the top and then slowly pull it down to the right position. Oh, sorry, God, I nudged the microphone there. My apologies. I may as well refocus the camera. Hello. Ooh. All good. Do not minimize. I can just check on the stream the camera is still. I'm glad. I thought I'd struggle a lot more with minimizing the camera, but I'm glad I haven't actually had to deal with that. Thank God. All right, that's cool. So, oh yeah, I should point out, by the way, I forgot to mention I'm wearing a hat just because I had a haircut today. My hair's always pretty dodgy day one, so I decided, hat sounds good. Hat vibes. I just like wearing hats in general, although I don't usually wear these caps. I'm not that much of a fan of those. I just have full woolly hats, even if it's the middle of the summer. I'm just like, derp in your face. Okay, cool. So let me just budge the fan over a bit. Just to get it fully ventilated. So yeah, for the time being, I'm not going to be actually just one sec. Cool. For the time being, I'm not going to be because I'm inexperienced and because of all that stuff I mentioned about, sticking to standards of locking and unlocking and just being careful about all that stuff. I'm not going to crack down on code duplication too much. This snippet of code is going to be the same for leader, follower, and candidates, sure. But at the same time, moving it somewhere else means that I split a lock-unlock pair, and I just do not want to have to even think about that, so I'm going to avoid it. So yeah, just a bit of basic manipulation there. Leader check, follower check, and candidate check, all exactly the same pieces of code, I'm pretty sure. Just duplicates it. And then there's you see there's an unlock here immediately after the follower check, and same for the candidate check. Oh lol, not even the same for the candidate check, sorry. So just the follower check. Candidate and leader check don't have an unlock immediately following them because, I don't know. Reasons. It depends on what they're doing. My standards at the moment are I'm fairly specific about when I lock and unlock. I read MIT's advice, and they basically say anytime you use these variables in any way, you should lock and unlock. Even if you're just reading them, which I don't actually believe is necessary. If you're just reading not an object, but a primitive variable, like current term. If I'm just reading that, I don't think I should need to lock it, but MIT was MIT was insistent on the matter. My debugging stuff does not. It literally does not um, respect that at all. So I read from RF outside of locks all the time in my debug code, but I only allow myself to do that in the debug stuff because I can turn that off using debug.go. All those print statements, I just turn them off, and then if the program works, but it stops working after like the debug statement is turned on, debug statements are turned on, then I think I'll just be like, eh, can I even shrug on camera? I don't feel like my hands don't even fit on the fucking. Yeah, I think my camera might be a bit too close. I can't even go like, yeah, it's okay. So yeah, basically I could just be like, yeah, it's fine. I just turn it off and it works. All right. So let's annotate the rest of the code. Follower check is pretty simple. There is a timeout here, which is called the election randomization timeout. No, sorry, this is just the election timeout. Election randomization, election timeout. Okay. So a follower will always be running await election. The family is ranting again. It's such a stereotype, though, ranting in just like random foreign languages. It's not a very English thing to do. It's kind of like you notice a lot of Spanish people ranting. You'll notice a lot of Arabic people ranting. I would say Chinese as well. When I was in church, a lot of Chinese people ranted. English people, it's just kind of like people are just reserved in England. They just don't go on like that, and that kind of suits me because then I don't have to listen to this. But different strokes, different folks. So yeah, I'm gonna also put in heartbeat timeout here. Ooh, careful. Oh my god, my code editing techers are just poor. Delete the fucking curly brace at your peril. Heartbeat timeout. And then recurs. Yep, so here we have election timeout. The select is, what is this? What does this do? After the election timeout, what does the follower do? It doesn't call an election. How have I programmed this? So what is the follower doing? It's awaiting an election. There is a case here where it calls an election. So read this code, right? It's saying the candidate has timed out. Sorry. Oh god, my conventions, man. What was I talking about? What I said, yeah. When I write like a print statement that looks like this, my convention was rf.me, fine. That's just me, the number, which precedes every print statement, tells me who I am. You can see here. Candidate means I'm switching to candidates. Maybe I should put in like an arrow or something to say, but yeah, this just means I'm becoming a candidate, and this means I'm reaffirming that I am a follower. I'm still a follower. So putting it in my convention is a bit stupid, isn't it? Do you know what? I'm going to change my convention. So my convention is, so far, I just type the name of the phase if there is a phase change, and I just type the name of the phase in brackets if there is no phase change. So if I've just reaffirmed that I should be that same phase. I'll change that in a sec. I just want to finish what I was talking about, which is this is saying I want to become a candidate, I leave from being a follower, and I phase change to candidate. This is saying I want to become a follower. Sorry, I'm still a follower, so I just in a separate Go routine run my recurs on myself. So this is continue, recurs, or become candidate. Yeah, I'm just gonna. Do I want to use that arrow? Because I'm using that arrow for like send statements and shit. Do you know what? I hope this works. I hope Go is a modern enough language, but I am literally just going to use a right arrow, Unicode, to specify. My right arrow is to specify a phase change, whereas my right pointing curly angle bracket, sorry, my right angle bracket is to specify like a sending of messages. So I'm making the conventions up, right? So hopefully there's no problem just from me using this arrow. Follower is yeah, the flat line there just represents stasis. It represents nothing changed. So I'm just gonna. Should I use X as well instead of exit? I'm just gonna use X. Yes, I like that. It's nice and simple. It just says, you know, these are my states: follower, candidate, follower. Stays the same, becomes, exits. Okay, so simple. I will explain what phase change does later. It's kind of complicated. It's not that complicated. It just requires you to remember a few conventions. But yeah, I'll just go over that in a sec. So basically, heartbeat, I'm going to do the same stuff, you know. X leader here. X follower. But there is no becoming or changing, so there's nothing else to update here. Okay. And call election, I will just do the same thing. In this piece of code, I'm just going to, okay, X goes there. So I'm just changing the print statements. Becomes follower. Exits candidate. Becomes leader. Exits candidate. And this is candidate stasis. Stays, you know, remains the same. It remains a candidate in both of these cases. And this is my phase change code. I'll discuss that in a sec. But yeah, basically, just to bring it back to what we were talking about, what does await election do? Checks if the thing is a follower, then runs, you know, just waits for the election timeout to pass. Then it continues. It chooses whether to recurse or become a candidate. So it waits. The election timeout has passed. The election timeout has passed. Wait a second. Oh shit. This code doesn't work the way I think it does. This is a timeout, but the timeout doesn't get run in this position. This is what happens, sorry. Okay. So, okay, I confused myself. Basically, the code here that I've said, this timeouts line, this line, which defines timeouts. This is defining the election timeout, but it's actually only defining a duration of time in Go, which is election timeout plus election randomization randomized. This is basically the timeout is a random number between two numbers, and it is a duration of time in Go type theory. In the world of Go types, this is a duration of time type. I've added election timeout with a random number between 0 and the election randomization number, which is in milliseconds. Or is it in seconds? I don't know, it's in milliseconds. And you can see what those are just by going here. Randomization is 150, and the election timeout is 500, so it's 500 milliseconds. So this is a Go time duration type. 150 here is just a number, but that's because I needed to pass it into the random number generator, which it gives us a number between 0 and 150 inclusive. And then that gets converted into a duration by multiplying time millisecond, and then that gets... Well, you have to explicitly convert it for some reason, and then you just add election timeout and you get a full timeout. So, okay, to summarize, timeout is just defining the timeout. That's all it's doing. It's not... Oh, fucking... Sorry, moth. Because I have a meter by meter basically of open window here, and it's just the night time now, so the moths are coming. But yeah, timeout specifies the election timeout duration, and then we have this. This is actually one of my favorite bits of code from the project so far. Something I had to Google a bit to figure out how to do in Go. But basically, the select statement waits for one of these channels. It blocks until a message is received in one of these channels. Oh, fuck. Dear Lord. No, please. This is a fucking disaster. Oh no. Wow, okay. I am shook. I'm actually shook after what just happened. But you know what? I'm just gonna finish my explanation because fuck it. Okay, I'll explain what happened in a sec. But basically, what the hell was I saying? This is one of my favorite bits of code. It waits for one of these channels to become available. Okay, election reset is a predefined channel that I specified earlier, that I'll explain in a sec. And time.after timeout, this just in time creates a new channel that receives a message precisely after the timeout duration. Okay. Select waits until the first of these becomes available and then pulls the message off and works on it. Actually, both of these, as you can see, both of these, because I haven't written down a variable on the other side of this arrow, I don't care what I received from the channels, I just care that I received something. So this gets run after the timeout, which means that because this will definitely happen after the timeout, this channel will receive a message after the timeout. That means that this is guaranteed to run after the timeout. But because I said this waits for one of these, that means that this runs if and only if the message comes through before the timeout. Okay, that's basically what this does. I think that's quite clever. So just allowing for the print statements, which kind of say, okay, if there is an election reset message, it remains a follower. A reset happened, and it tail recurses. It runs the follower code again. Easy. If the timeout happens, then we transition to candidate and we run the candidate code. And that's all that this code says, okay? Election reset is a predefined channel, and there are various, I'm not entirely sure what all the different ways that something can send a message into election reset are. In my code, I can check that, but like in the concept, the concept, basically the way the concept relates to my code, is that something is sent into election reset if and only if an election reset should be triggered in a follower. The election reset channel, of course, resides... nothing is global in distributed systems. Every server, every peer has its own election reset channel. And it receives a message if and only if conceptually the election timeout should be reset. When does that happen? I don't actually know. There are various different cases. The most important one is, of course, if a heartbeat has arrived. So if any append entries RPC has arrived, election timeout should be reset. That's the idea of how the heartbeat works. That's absolutely fine. There are some other cases in which I said it would be wise to send a message into election reset. Election reset blocks. I'm not sure if I buffered that channel. I don't think I did. The election reset channel. No, I didn't buffer it. It's just a channel that whatever sends an election reset message must cause the thing to turn into a follower and receive the message when the follower code runs. In principle, I think that has to happen. Not entirely clear. It's not easy. You can kind of see why distributed systems is hard just from me talking about this stuff. It's not exactly easy to know, to be on, to have all. You have to implement the leader code, the follower code, the candidacy code independently of each other. Different servers are running these different pieces of codes at the same time in parallel, and they're in different phases at the same time. They send messages to each other, and so all the Go channels are a way of achieving concurrency in Go that is unlike RPCs. RPCs are communicating between servers. Channels are within the server communicating between threads. That's how Go concurrency works. That's just it. So this is what I'm saying. Channel sends and channel receipts. So here is a channel receipt. I'm pulling out of the election reset channel here. This is something we don't care about because it's just a channel I made just in time and it will send a message. And if the message doesn't come, well, the message will always come, but I think that channel just disappears. I guess garbage collected. I'm not entirely sure that actually happens, but I think it should do. Yeah. But like I said, implementing the send side and the receipt side and making sure that you're on the same page when you write both pieces of code about conventions like should the thing definitely become a follower after it has sent a message into the election reset? This kind of expects it, because if that doesn't happen, election reset might get blocked, or will it's not completely clear, and you're thinking in terms of these hypotheticals is not worth it, I don't think. I'd rather take a slightly more practical approach and just have code that I know how it works on a basic level, if not being able to predict the full chaos of running the whole system. The individual pieces of code, I know how they behave because I know how channels work. And then just test it and hope that you can connect the output that you're seeing with your understanding of each individual small bit of code, right? If you see what I'm saying. So yeah, just basically doing that is basically what I care about. God, I love that. Look at the complete lack of motion. What's the word I'm looking for? Motion blur. Yeah, because it's a good camera. All right. That is how this works. Let's have a look at call election. I think this code, as you can see, became a bit complicated, a bit convoluted. The election code. So what the candidate does is a bit messy. Okay, let's look through that. I'm only going to be live for another 20 minutes, I would say. I'm definitely going to stop after that. So I'm going to try my best to just run through my codes, through the rest of this so I understand what's going on, and then through the RPC bits of code as well. Hopefully I'll have time. I'm not sure I will, but hopefully I'll get through all that. And the next thing that I'll be doing after I do those is I'm going to go through the blueprint and my skeletal summary, because I like going through my work first because I did it first of all, so I have a better understanding of it, but also because it's practical and I can see exactly how it works, so I kind of get a better idea of how the program works compared to how it should work, the concept, the sketches, all that stuff. which are also easier to understand when you have some practical grip on what's going on. So it's totally fine to just do it that way. But now, yeah, I have to break up the call election code and figure out what is going on. I can just... This is a bit strange, isn't it? I can just... rf.currentTerm is already an integer. This code will work equivalently if I just write it like that, I'm pretty sure. I defined the term variable within the lock, but that doesn't matter. It's not like it gets trapped to the log or anything like that, you know, encapsulated by the log. I'm not using the right word there. I don't understand why these guys like to just shout through the window all the time. Like, what are they doing outside? Are they just sitting there the whole time? I honestly don't know why it would. I've never actually seen anyone do that in like 17 years on this estate. It's hilarious. Like, he's talking through a window and he's just shouting so loudly that you can probably hear him on the camera, as in on the microphone. Alright. What does call election do? Let me try to understand what the hell is going on here. I increment current term. Okay, so every election starts with my own term being incremented. I then define a copy of the term variable. Unlock the lock and do some vote rigging. Do some. I call an election. So it's like, okay, votes. I make a channel to collect the votes in. Vote count is I make a counter variable to count the number of votes. Majority is the number of votes. It's an integer. You know, the minimum number of votes required for an election to pass. Sets up votes. That's the first thing I do, and then it's like request votes via request vote RPC. So replies is a channel. No, it isn't. Replies is an array of vote replies. Okay, this is where I'm going to store all the replies for ease of reference, and its length is the number of peers. When it says pointers, I don't know what I mean by that. I mean, yeah, it's as in, is it request vote replies or pointers to request vote replies? Okay, fine, I'll leave that comment in for now, but I think it doesn't matter for some reason. There's probably a theoretical reason. You know, in Go, you don't always have to use pointer notation, and the times you don't have to use it is when it's obvious that it's whether or not it makes sense to use a pointer. So in the case of this, it's an array of request vote replies, a slice of them, and in that array I am storing, quite clearly I am storing pointers. Is that what's happening? Oh wait, no, that's not what's happening. I do not understand what these people are doing. Woman just came up to the window and just like put some like something underneath it. Like it's not like that's a window ledge, it's just on the ground, which is quite moldy because like the pipes on the walls leak all the time. Je ne sais pas. Je ne sais pas. Right. Yeah, this is not pointers. As in the way I've coded it now, it's not pointers. It's literally a slice of request vote reply structs. This is where I define them. And so it's like the request vote reply corresponding to peer, one of the peers, is this array, the replies array, at index that peer. You know, and therefore the maximum index is rf.peers -1 because it's 0 indexed. But yeah. So this is where I define the replies position, where to save the replies. You know, I increase increase term, set up a vote channel, vote count, majority number, set up the replies channel, just all the boilerplate. Then I send them all out. I have to vote for myself, so therefore if the ID is me, I just send a true into vote. And else, this just loops through all the peers in the cluster. If it's myself, I send a vote to myself. If not, I define just in time. Okay, so I'm saving all the replies in an array, but I'm defining the args. Don't forget, the args is what the sender sends, the reply is what the receiver sends, right? Or what the sender receives. Those two structs. For every RPC has to have those two structs and the two functions handling it. So the args struct, the sender information, I'm defining just in time, whereas the receiver information I defined in an array beforehand. Like I'm gonna be saving into that array. Ooh. This is a violent moth, sorry, but yeah, the moths are a bit of a problem. Hopefully this one will have just left. I really don't want to. I just turned the light off just for the time being, but I really do not want to. I really do not want to close the window because that could compromise the laptop heat, basically. So the laptop is pretty good now. It's been running at really quite cool for a while because of the fan, 60, 70 degrees. But yeah, the moth. Well, I just saw the moth leave using my night vision, so that's all absolutely fine. Oh, you can actually see me on the webcam. You can see the motion blur has increased, but it still works. Do I dare open the window again? As in, okay, do you know what? I'm going to close the window to half of what it was. And correspondingly pull down the drapes. Drapes the earth. And yeah, I'm just going to chance it and hope. The reason I'm so paranoid about moths, by the way, what left me shook, I just realised I haven't spoken about that about 10 minutes ago. Basically, yes, the camera all set up. Just to zoom it out slightly, just waddle it out. Basically, mate, yeah, one of the moths just stone cold flew through the fan. There was just a ding, and the moth just basically flew at me, half chopped up, struggling to survive, just flying slightly, and I was like, what do I do? What do I do? I just managed to blow it off the side of my bed, and now it's just dying under my bed. It's just bloody nightmare, seriously. Moths are just a disaster. It just flew into the fan because it's on levels of intelligence. I mean, a fly would never do that. Flies are great. Flies are such a great insect. They're so intelligent, if you think about it. Okay, cool. Only another 10 minutes of this, I promise. I probably won't have time to go through append entries and request vote. Okay, maybe 20 minutes, but yeah. Cool. So yeah, I was rambling about an unimportant implementation detail, I think. Args, the sender information, which is request vote args, is made just in time. The receiver information is just stored here for later. And then I do the send request vote, I run that in separate Go routines. And then I'm going to await for all the votes to arrive in votes true. So, requested votes. Cool. Maybe I should write rf.states. Because I've been explicitly writing down states. I just noticed that. No, but I'm not introspecting state that much. I'm just kind of... maybe I should do that, I'm not sure. I'll think about it later. But yes, I await votes by looping on the votes. First I check if vote count has achieved the majority. Greater than or equal to the majority, and I break if that's happened. Otherwise, select I'm awaiting votes. And if votes is true, I increment vote count, but I just keep awaiting votes. And if that has not, if an election reset has happened, take a look at this. So the reason I have select here is because I'm not just looping through this and waiting for all the votes, but also whenever I encounter this select statement, if an election reset has been triggered, I turn into a follower and exit from candidate. Votes is interrupted. That I remember reading in the blueprint that is supposed to happen. Like if something has become a leader, I've called an election, but if I've received the votes from anyone, maybe I should do a term sync. No, I shouldn't. This is what I mean. Like, do I do it on one side of the channel or the other side? Election. So look, this is pulling from election reset. If something has sent a message saying the election should be reset, then yes, I am turning straight into a follower and exiting from being a candidate. Okay. But the send into election reset should happen if a heartbeat arrives, but not a heartbeat from anyone, but a heartbeat from somebody who is up to date on term. It's these kinds of details that make it work. It's like such a I can't even. It's just like you can't know that. You have to have been there. You have to have failed once at least to get it straight in your head. Exactly the intuition of like when exactly should the election be reset. It's not completely clear even if you read the paper, like because it's so complicated. You can kind of see as I'm taking you through all this, it's just kind of so complicated. There's so much stuff going on, and I've only implemented the stuff I've done is pretty much precisely what's necessary for part A. Part B is I'm gonna be putting in the data phase, but part A I think is actually the hardest part, to be honest. Part B is really complex, but I don't think it's as hard as part A because part A requires you to keep track of all the phases and all the resets, timeouts, and the whole election procedure. Whereas part B just requires you to synchronize individual data transmissions. I think it's equally hard because that is also a multi-step process, and it's not that easy, but it's okay. It's okay. Again, take a look at my Twitch page, the bottom right corner. If you're on desktop, there's a section on resources. The illustration of Raft. Take a look at that. I kind of have that in my head. That's one of my pieces of intuition. I'm kind of thinking about that, with everything that I'm doing. So yeah, that's what we're about. Yeah, that's it pretty much. So this is allowing an election reset to happen. If that happens, it just quits this code and does a phase change to follower. Otherwise, it keeps on pulling votes, and every time a vote is pulled, it continues the for loop and checks if we're on the majority. This is the thing about votes. This is awaiting votes, so it's awaiting votes, which is a Boolean channel. So it's either going to get trues or falses. So if vote is true, vote count gets incremented. If it's false, it just gets dropped. But either way, we are at all times keeping track of all the votes within vote count. And that, therefore, vote count greater than or equal to majority is guaranteed to happen. Because this loop will always finish, and all the votes will be registered in vote count before, it gets triggered at the end. Oh wait, no, that's not necessarily the case, because this needs to be at the end of the loop. What am I doing? Who am I kidding? This needs to be at the end of the loop. It works fine at the beginning. I think usually it's good to put checks at the beginning of loops. So you don't run redundant code. But in this case, really the vote should happen and then the vote counts. And the vote count is always happening after the vote, because that means that the break is guaranteed to happen. this piece of code is guaranteed to happen, and we should not even need to program what happens after here. It should always go on to the decision, but I'm happy to just leave it as, if vote count greater or equal to majority, break the for loop, even if we're at the end of the for loop, whatever. But we don't have to recount the votes. This is kind of important. Am I recounting the votes? Oh yeah, I am actually. If vote count is greater or equal to majority, break. That means that we have received votes. Let me be a bit more careful about how I program this. Oh yeah, if it loses the Nah, I may as well just test vote count greater or equal to majority twice. I may as well just do that. Vote count greater or equal to majority has to be tested, by the way. It cannot be tested after the vote is done because there is every chance, this is a bug I ran into last time, there's every chance that somebody has stopped replying, and so you will never finish the vote because this waits for everyone to reply, but that's why I have a break here. So this situation of lost vote is everyone replied, but the vote is lost. That's pretty rare. It's more likely that you're going to get a vote interrupt or or indeed an election. This code is it is quite messy, is it not? Let me just I'm gonna read through it and see if I can decipher it and maybe do a bit of refactoring here. If the phase is candidate and vote count is greater or equal to majority. Yeah, it's basically a three-way if loop, so I'm testing is it if look, lost candidacy, but then it caused another election. That should definitely not be happening. If there is a phase change, then the code that is running any of the other phases, namely this, which is only supposed to be being run by the candidate, should exit ASAP. There should definitely be a return here. Like, lost candidacy means, like, I'm not a candidate. You should X candidate. Surely there should be a return here as well. Oh no, there shouldn't, because that function automates. Yeah, this is what I mean. I'm being a bit messy here. Look, I'm gonna put the codes for continuing here. The for loop happens. If the for loop expires without break, dear Lord, kitchen. Yeah, sorry, what was I saying? Yeah, what bothers me about this structure of code is that I can't put the break code somewhere else. Vote count greater or equal to majority. I have to test for it. I have to do this test again if I don't want to put the code in here. Okay. But that's fine. Just do that. I'm happy enough to just do a decision. I'm gonna call this the continue phase. Yeah, so I'm saying I'm happy to have vote count greater or equal to majority tested twice. That doesn't bother me. But definitely, definitely what you want to do here. I cannot use defer anymore because my phase change doesn't allow it. That's so sad. Never mind. These assumptions and assertions. Nah, let's not worry about that. Yep, so listen. basically, I am going to rewrite this piece of code. First we lock, because the continue section I'm going to rewrite. First we lock because we need to check what the phase is. So basically I'm doing a phase check again. So let's just copy out the candidate check. So yeah, in the time that this has, this has been waiting for votes and all that, there's every possibility it could have lost the candidacy in a different way. Not necessarily an election reset, but it could be that something else has caused it to become a follower. I definitely would not want to have to assert that election reset is the only way that this can become a follower. That's very limiting. So instead I'm just going to copy, straightforwardly copy out the candidate check. I'm going to straightforwardly copy out the candidate check into the first thing that I do here, basically, in the continue section. In fact, yeah, let's not call it continue at all. First section is going to just be candidate check 2. For consistency, I'm going to just chuck this here. RF mu lock, candidate check 2. Okay, so, if at this stage RF phase is not candidate, I unlock the lock, and just say, okay, I've X'd candidate return. And you can I can say why did I X candidate? I lost candidacy. In fact, why not just call it check 2? And this X candidate here, I'm just going to call it check 1. That'll give me a bit more information when debugging. I like that. Okay, so I've done I'm doing, candidate check 2, and that returns if it fails, and so continue. So I don't have to keep checking if I'm a candidates. RF phase candidate no longer needs to be checked. So RF phase candidate, that happens anyway. Don't need that anymore. I don't need the mutex at all anymore. In this section, rf.mu, the state variables of RF are not being touched by anything other than the print debugger, which I can turn off, and I'm allowing myself to, as I said earlier, I'm locking every interaction with RF state variables, like for example phase. Every interaction with those it has to be within a log, according to MIT, even if it's a quick read. But that is not something I'm sticking to when it comes to debugging using my P. The P's are print statements that I can turn off. They're my debug print statements. Those I'm just allowing myself to do atomic reads of small pieces of data, primitive types, RF me, and RF phase, basically those two. But other than that, yeah, there is no other state variable reference here, so I just don't need the lock. I'm going to unlock here. This is unlock and return. And this is just unlock and continue. Don't have to write the word continue. So no need to unlock. Let's ditch the other unlock statements. I think my convention is that I write this as conversion to leader, do the phase change, and then say X candidate. And here I'm just candidate lost votes, tail recursion. So yeah. So the code, I've rewritten it here. I haven't really made it shorter, but this is wholesale copy and pasted from the previous section now. And this is just saying, okay, I am still candidate, this is my continue logic. If vote count is greater than or equal to majority, I'm just going to turn into a leader. The same way I've always been turning into a leader, or any other phase change basically has been looking like this. And else, if that doesn't happen, then I am still a candidate. My print debug statement is saying I'm still a candidate, I lost the vote, because that's the only way that can happen, because we've continued out of this block that counts votes. That means that everyone, the length of the number of peers, all the peers, we must have awaited. We must have awaited a vote from them, because if this was ever triggered, there would have been a return. And this is not true if there was a break. So that's my point. If this is not true, then there definitely was not a break. That wasn't very conveniently explained, I'm sorry, but basically, in this case, yeah, we have definitely lost the vote. We're definitely vote count less than majority, because the break is vote count greater than or equal to majority, and the election reset that would have returned. So this must be less than that, and the whole for loop must have gone through. So we lost the election. Everyone voted, but we don't have a majority. Okay, and that's that. That's the tail recursion. I'm clear on how that works. Okay, well, I'll check the message just before I continue into all that other stuff. Wagwan with the random comment. I've done something that's really wrong and I need some help on how to disappear and be under the grid. Please help me. I need to be invisible. Someone who needs to be invisible. You found the right place. I think, most streamers who are popular enough, you wouldn't ever reply to that kind of message. You're like, what do I say to that? But I have the time, because I'm not trying to handle a video game or a speedrun or whatever. I can just be like, yeah, I'm just gonna slack for a bit and reply to the message. System out print learn kappa. Yes. Well, yeah, that's what my P is doing. I am printing. Where have I defined that here? Yeah, pretty much. But thankfully I haven't riddled my code with print lens, because that would have just made it awful. Yeah, man. Thanks for watching. Yeah, I'm pretty much. I'm gonna leave before midnight, and the reason before that is because I want to make sure I've sorted all of my gifts in Pokemon Go, because I do those at midnight. Pokemon Go gifts. And also, it's kind of getting hot. My position is a bit shit. I'm getting sweat under all of my pits, and I don't know why I'm still wearing this hat. Yeah, I'll ditch the hat for a bit. Why not? So I'm not gonna stick around too long. Definitely 10 minutes max. But for the time being, what I'm doing is just flicking through my code so far, and literally just trying to remember what it is after 6 weeks of break. So all I need to look at is phase change, and then the append entries and request vote, and then I'm going to look at my theoretical notes, the scrap that I wrote down, blueprints, kind of get the stuff I've done so far and the theory to sync up, and then continue actually. Move on, do part B, MIT Distributed Systems coursework. Fuck's sake. This is not it. This is not it. You would be. People are still really surprised because Pokemon Go, obviously, massive hype arose around Pokemon Go. On release, and it was just everywhere in culture. And then it just died because the developers completely incompetent, and they just allowed it to die. But then, like July 2017, so 1 year later, they introduced a new raid mechanic to the game that, like, so many people are now playing it, and that hasn't stopped. So many people came back to the game, and so you still get massive Pokemon Go meetups. The game just came back from the dead. It's not nearly as much as like 2016, but so many people. And for me personally, I'm mostly bored of it. But like the gift thing is just kind of fun for me because I have a system for how I do it, and it works pretty much perfectly. And so I'm just like, yeah, let me just maintain the system. I have like a spreadsheet because I'm a fucking nerd. But that's it. Yeah, yeah. Do you know what? I'm not gonna do any more work. Shall I go through phase change? Phase change. Leader to follower to candidate. Uh, yeah, yeah. I may as well. That'll be the last thing I do, I think. Um, oh, actually, one thing I will mention about Pokemon Go. I do bots work. Well, not the actual bots that play the game, but I was doing notification bots for Pokemon Go. You can see those on my GitHub, which is linked somewhere down below if you're on desktop. But like, I was moderating the server, and before the raid update in summer 2017, it had 700 members, and 3 months later it had 7,000 members. And I was just chilling there, like developing bots that were getting used by suddenly hundreds of people, thousands even. I think. I mean, would have come into contact with it, although it's mostly fucking alt accounts, isn't it? But yeah, it was kind of nice to do something that was so useful to so many people. But at the same time, that shows just how popular the game became. And in London, we still get those meetups of 100 odd people. It's good fun. Catch a hype pretty much. Even if the game is really stale now. It's just RNG and nothing else. Pretty much, there's no game left. All the game pretty much died out. Other than this gift system. Alright, phase change, and then I am done for the day. I'm gonna come back like I planned tomorrow. Tomorrow at let's say 11 a.m. It's so hot in London at the moment, 30 degrees. The earlier I can do it, the better. Seriously, 11 a.m. is the one. And I might even not stay for long. 1 or 2 hours, I don't know. But tomorrow at 11 a.m. BST, British Summer Time, which is it's the summertime of GMT, which is UTC plus 0, so whatever your time zone is. It's the London is on 0 during the winter, so now we're on +1. Alright, let's go through phase change. So phase change is a bit of code that I made. I mentioned earlier I'm really hesitant to abstract bits of code out of this because of the lock, basically. The lock is what's causing the problem, because I have to lock and unlock precisely. If you unlock this an unlocked lock, the thing crashes. If you lock a locked lock, it crashes. You have to be careful. So that's why I'm mostly not. I have bits of redundant code. So I'll show you, like, candidate check. Ta-da! And then I scroll down. Candidate check 2. Same thing. I'm not abstracting because there are locks and unlocks all over the place, and unless I can come up with a consistent convention for how I'm going to do that, which with a bit more experience I think I'll be able to do. At the moment, I'm happy to just leave copies of code because it's quite clear what it does. I've commented it decently now. It's okay. Phase change is the one thing I have abstracted out. Perhaps as an experiment. I don't remember why I did this 6 weeks ago, but phase change is abstracted. Phase change is called, the Raft cluster, all the servers are in a phase. leader, follower, candidate. And they can be in any phase. All of them run exactly the same code, but then they collaborate because distributed system to ascertain who is leader, who is follower, and who is candidate. And so a phase change is run. This is my assertion. This is what I decided the code will comply with. Phase change is run only if I know I am in a phase that is not the one I want to be in and I want to transition. So I'm running phase change when you're already in that phase for like redundancy or whatever, just to be on the safe side. Very bad. Do not do that because you will run multiple copies of the follower code, for example, and that will cause multiple election loops, and it will just get chaotic. Multiple candidates will just call repeat elections, and like fuckeries will happen. Put it that way. So that's why phase change is quite clear. It's like there's a clear if from phase is not equal to two phase, set the phase, unlock the thing. Okay. Two phase is the phase I want to change to. Sync is whether I want the next code, the code that starts I have init initializing codes for all the phases, which gets called whenever something turns into that function. So you can see those functions are here in a dictionary, init, leader, follower, and candidate, and these are the phases that they should transition into. So if the two phases, I want to transition into that, so I'm running that code. And sync is whether that code should be run in the same context, in the same thread, or whether I'm starting a new Go routine for it. So this is how it works, okay? Initialize phase, leader, follower, candidates. I do the lock. I pull the from phase, which is my current phase. And if that does not match the phase I want to change to, that's good. If it does match it, I do nothing. I just unlock and return false. But if it is true, actually I've just noticed this code always returns true. So just for clarity, I'm going to rewrite this with an else statement, which just makes it clear that the return false must always happen and the unlock. In practice, if I don't return, it will just okay. So this is something a change I've already tried to make, but the Go is telling me that it's not happy with that because of some arbitrary convention that the fucking linter is enforcing. I mean, fine, I will comply with its conventions, but I'm not happy about this. I think the code is more legible if you have else, even if it's unnecessary. Yeah, anyway, so the interesting case, if from and to do not match, I need to leave, man. 10 minutes to sort out present. The phase is set to the to phase. The mutex is unlocked because I don't need it anymore. And then I decide, am I running? If I'm running synchronously, I just straight up run init phase. Else, I start a Go routine and run it. And I return true. The return of true, careful. If the Go routine is run, obviously in this context it just continues and it returns true immediately. If the synchronous routine is run, then this only returns true once this is finished. It blocks and then returns true. So return true is actually useless because this doesn't return. The phase changer doesn't return if something is being run synchronously, which I do not know how to make that happen. I'm not sure it's possible. It's fine. It's not important. It's just that the return statement here is not important. Basically, it's the success or failure. Just forget about it. I could just write this just to make the code slightly clearer, as in what I'm expecting it to return is did it succeed or not. It just doesn't return it at the right time in the synchronous case. But thankfully the synchronous case is mostly useless. I do want to run it. I'm not sure I even want to ever run it. I've just left the option open for myself. To just run the code one after the other. Who knows? Alright. Guys, I'm done. I'm out. I don't have enough time to do anything else, and only 9 minutes to cut the stream and do my gifting shits. I don't know. Might spend a bit of time watching Linkus I've been watching stream Wind Waker HD. I don't know if he's up streaming at the moment. I'm not going to do like a raid or whatever because audience is minimal and it's not programming up. I don't want to do it because then I have to like turn it off and think about it. To be honest, that's the only reason. Otherwise, yeah, why not? I like the guy. He streams. He's a good streamer. Very positive. Great fun to watch, and his chat is pretty good. Okay, well, what I will do, yeah, I'll push it all to GitHub, the stuff I've done today, and like I said, okay, let me just do a quick summary of what's happening next. I continue tomorrow, 11 AM, I'm continuing just for a bit, and then I will probably continue on Friday after that, because I think Thursday's busy, and Wednesday, I'll continue on Wednesday if I want to, but I'm not sure I want to do it twice a day. So, tomorrow's Wednesday, right? Yeah. So that's all good, that's all good. What I'm going to be doing is continuing with the recap. The part of the recap I'm going to be working on is I'm going to keep going through my code. So I've been through phase change. Next, I'm going to check the append entries and request vote RPC implementations. When I'm done with that, I'm done looking at my code. I know how it works. You know, I've internalized my own code, so I'm pretty tight with it. And then I go through the blueprint, and I have scrap notes that I made before in the blueprint. And so I'm just going to try to go over the theory again, so that I know what I'm implementing, and see if I can connect them up, like the theory and the actual code that I've made. Right, my code, get it to match the theory of what it's supposed to be, because the instructions from MIT say it should match the theory as close as possible, and the theory is as specified in the blueprint, which is from a figure, an image from the Raft scientific paper, which you can find on desktop on my stream, bottom right corner is called Raft Blueprint. And I have a copy of it here as well, which I'm not going to look at for the time being. So that's it. Back at 11 AM. Yeah, slightly awkward that I said I'd be back at 12 AM, but I'm just going to edit that. Just going to edit that, and it'll be up on the stream title. And really, you haven't missed much if you missed the 11 AM. I'm just continuing through the recap, and the recap is long and arduous and winding. That's it. That's all to say for tonight. Thanks for dropping by. Bit of chat. Always nice to have a bit of random chat, a bit of random breeze, like all that. Okay, that's it. Thanks for stopping by. Peace out, guys.